Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone, ladies and gentlemen. Welcome back again to the second day of the 5th International Conference on Food Security and Sustainable Agriculture in the Tropics. It is wonderful to see you all again, both here at the Faculty of Agriculture, Hasanuddin University, and joining us virtually via Zoom meeting. Following the success of yesterday's session, today we will continue with invited speaker session and parallel presentations featuring experts and researchers from various institutions and countries. Before we begin today's session, we would like to express our sincere appreciation to all participants, organizing committees, and supporting partners for making this event possible. We are also honored to welcome our invited speakers who are experts and researchers in the field of agriculture. First, we have Mr. Liu Hongthe, an international sales manager from Group Gain Bioagri Co. in Taiwan. He is an expert in agroecology, nature-based solution, and smart agriculture development. He has over 10 years of international experience in agricultural development and cooperation under Taiwan ICDF programs. He also served as project manager and agricultural specialist in Nicaragua, Papua New Guinea, and the Philippines. He is also an expert in agroecological revitalization and integrated crop management for sustainable food system. We also have Insinyur Mukhlis Bahraini STP as the CEO of Pachira Group Indonesia. He is an agro-industrial innovator and technologist in food ingredients. He is the founder of the PT Pachira Distri Nusa and innovating in functional food ingredients with over 30 years experience in research and development, marketing, and food technology. The company collaborated with Germany, USA, China, and Thailand on extraction and processing. He is also the advisor to Kemenperin, Kemenristek, BRIN in industrial innovation. And our third invited speaker for today is Professor Dr. Damayanti Bukhori. She is a professor of ecology and entomology in IPB University Indonesia. She is an expert in agroecology, biodiversity, and sustainable landscape management, Director Center for Transdisciplinary and Sustainable Science in IPB University. She also acts as Head Biological Control Laboratory, Department of Plant Protection, Faculty of Agriculture in IPB University. She was also a former president of Indonesian Entomological Society, Project Director ZCSL UK CCU Sustainable Landscape Program, or Kalola Sendang in South Sumatra, and also lead researcher on pollination ecology, biological control, and agroecosystem resilience. Before we proceed, allow me to remind all the participants that following this invited speaker session, we will also conduct the parallel session for research presentation. This session will take place both online and offline, where the online session will be divided into two parts, a morning session and an afternoon session conducted via the provided virtual meeting links. Meanwhile, the offline session will be held here at the Faculty of Agriculture in Hasanuddin University. Please make sure to check your assigned session and room as listed in the schedules provided. Ladies and gentlemen, we shall start our first agenda on the second day of 5th FSSAT 2025. We will have three experts, as we mentioned before, in agriculture as our invited speaker, who will share their thoughts, perspective, and experiences to us. This session will be led by Sir Muhammad Junaid, SPMP PhD. Ladies and gentlemen, please welcome Muhammad Junaid, PhD.
Um, well, thank you very much for master ceremony to introduce me and then uh, also to introduce my job today as a moderator for a session invited speaker. Well, I would like to inform to the our three invited speaker today, Professor Mr. Lee Huang Si, yes? Is it right? Mr. Lee Huang Si. How are you, Mr. Lee Huang Si?
Yes, I am.
All right. Is it morning there or what? We are in
Now
Makassar.
we are at the same time zone.
All right. Good. All right. The second speaker is Mr. Muhlis Bahraini. How are you, Mr. Muhlis? Hello. Okay, sorry. Hello, Mr. Muhlis Bahraini. How are you? Hello. Okay. We next to Professor Damayanti Bukhari. Professor Damayanti, how are you, Prof? Okay. So today only one invited speaker respond me. I don't know why, but means that we can kick off our first plenary session today with Mr. Liu Hong Se. I'm not repeat again about who is Mr. Liu Hong Se because of very clear and Master Ceremony spoke before. And are you ready, Mr. Liu Hong Se?
Okay. Yes, I'm here.
Time is yours. The time is maybe
Okay.
20 minutes presentation, and then we will be discuss about maybe 30 minutes later on. So keep going. Thank you very much.
Okay, so everybody can hear me clearly, right? Now?
Very clear.
Okay, thank you. Hi, so also my slide is okay? My presentation slide is okay now? Okay, thank you. Let me start. Okay, good morning, ladies and gentlemen. It's a pleasure to be speaking at the 5th International Conference on Food Security and Sustainable Agriculture in the Tropics 2025. I am Liu Hongze, but also known as Fabio Liu is much more easier for you. I'm the manager of the international department at Group GAN. Our core value is building a shared home for nature, ecological and non-toxic agriculture. Yes, like I said, I'm the manager in the group game. Our value is to building a shared home for nature, ecological and non-toxic agriculture. Today, I'll be discussing the topic of from friendly farming to agriculture sustainability with a focus on the concept of prevention agriculture. We will proceed in three parts. First, worldwide agriculture policy and trends. Second, core technologies and materials of group GAN. And finally, application and practice. Global agriculture currently faces four major challenges. First is the impact of climate change, where droughts lead to dry, compact soil, while floods cause nutrient loss, and there are more issues awaited to be solved. As you can see, traditional crop management often relies on experimental judgment. This approach often leads to the overuse of input, such as pesticide and fertilizer, and result in a significant environmental impact. However, modern agriculture must transform. Our goal is to shift to integrated crop management. We call it ICM, integrated crop management. This transition represents a shift from traditional extensive management toward a future of precision and sustainability in agriculture. As we know, excessive fertilizer application also presents problems, including soil degradation and decreased microbial activity. It also leads a reduced resilience in crops, increasing their need for pesticide and increased production costs. To address these challenges, the world is shifting toward eco-friendly farming, with the UN encouraging farmers to use fertilizer and pesticide responsibly. Biotech innovations are key. By precisely managing crop growth and pests, we can greatly improve how efficiently pesticides and fertilizers are used, reducing farmer costs and risks. This is the goal of ICM, again, Integrated Crop Management, ICM, which enables data-driven strategies, circular resource utilization, and a reduced environmental footprint. Okay. Group GAN's core strength comes from 40 years of material preparation technology, and our core values are concentrated on environmental friendly, scientific innovation, farmer welfare, and sustainable development. Our professional fields cover four areas. First, eco-friendly agri-inputs align with sustainable agriculture trends, reducing negative impacts. The second, microbial preparations improve the soil health, enriches microbial colonies. And the third, plant biostimulates, enhance plant growth and stress resistance, improves crop quality. And the final one, customized solutions, provides technical support and cultivation schedule planning. The next, let's delve into the key efficacies of Group GAN's products. Our eco-friendly inputs primarily deliver benefits in three areas. First is the repellent effect. This helps preventively drive pests away from crops before they can cause damage. The second is pest and disease control. We adopt a comprehensive strategies to effectively manage various pathogens and pests in the field. The third is enhanced penetration. This ensures that the active ingredients are better absorbed and utilized by the plants, thereby increasing the overall efficiency of the product. As an example, our product Nevermind is a formulation based on citrus essential oil. It combines the properties of repelling insects and inhibiting bacteria, and is one of our plant protection agents. Please look at the picture, which shows the actual field application of our Nevermind product on a papaya. The magnified insect clearly capture common agri-pests, such as aphids and mites, infesting the papaya leaves and flowers. Nevermind, as our eco-friendly solution, is designed to effectively manage and control these infestations. Our Nevermind product, a citrus essential oil, is used managing papaya mite infestation. Trial shows at the 1,000 dilution ratio, its control efficacy reduced 88.8% in the fourth survey, closely comparable to a chemical treatment at 90.5%. For other instances, our 5% pyrochitin has three main benefits: induce plant immunity to resist disease, improve soil properties to enhance structure and nutrient availability, and control pests and diseases, inhibit pathogens, and repel pests. Okay, then please look at the picture. 5% pyrochitin has also been successfully applied for melon poultry mealy control. The image clearly shows that the melon treated with 5% pyrochitin exhibits better health than the control group. And next, let's look at another significant contribution by Group GAN: circular resource utilization. How do we transform waste to high-value agriculture inputs? As shown in the image, large quantities of fish waste, such as fish offal and hate, are typically sources of environmental pollution. Group GAN utilizes biotechnology-driven catalysis to efficiently decompose and transform this waste. This transformed and product is one of our core products, AgriKing number 2. This is a nutrient-supplying fertilizer which high organic matter and natural amino acids that promote crop growth, enhance stress resistance, and improve soil health. Importantly, it achieves a win-win for both the environmental and the economy. We solve the waste problem while providing farmers with a natural, high effective, and cost-efficient fertilizer. Okay, the final one. Our solutions are based on principles of integrated crop management, ICM, adopting comprehensive strategies to control pests and disease. These include soil health, variety selection, plant diversity, and water management. To enhance agricultural resilience, our work also incorporates the three phases of disaster management: mitigation of impact, preparedness for potential risks, and effective relief following an event to shorten the recovery time. Ultimately, these strategies transform into a practical applications, such the customized solution for guava. Successful outcomes include reducing fruit drop, mitigating pests and diseases, and conserving soil water and fertilizer. This visual of thought culture demonstrates our concrete action to improve soil health and enhance crop yield and stress resistance. Our customized solutions, such as the one for guava, bring multiple advanced benefits. It can improve economic benefits, enhance fruit flavor, and improve nutrient utilization efficiency. Crucially, it combats flowers and fruit drop and activates the defense mechanism of plant. This is all based on a sustainable implementation loop, starting with research questions, moving to provide practical solutions, and ultimately establish an eco-friendly system, forming a constantly improving agricultural ecosystem. How do we turn sustainability into profit? Let me show you a business model. This is our crucial agriculture business model. The farmer's income is starting point of the sustainable agriculture. We first sell exclusive fertilizer for guava, ensuring high quality output. Then we sign a contract and purchase this high quality guava and sell it to the restaurants, achieving a complete cycle and return. And final one, this is my conclusion. The practice of sustainable agriculture requires ecology as the foundation, cross-sector collaboration, industry revitalization, and talent development. Our goal is to ensure a long-term balance between the economy, society, and the environment. Group GAN is committed to being a sustainable agriculture practitioner, realizing the vision of from friendly farming to agriculture sustainability by providing practical solutions and establishing an eco-friendly system. Okay, thank you for your attention. We look forward to working with Hasanuddin University, with all you guys, to contribute to food security and sustainable agriculture development in the tropics. Thank you.
Thank you very much, Mr. Liu Hongxi. This is a very effective presentation and then very clear the talk that we want to know for all participants here. All right. By the way, we are going to the second invited speaker, Mr. Muhlis Bahraini. Mr. Muhlis Bahraini, are you? Mr. Muhlis Bahraini. Good morning, Mr. Muhlis Bahraini. Well, if not, to be more effective, we go through the third invited speaker, Professor Damayanti Bukhari. Good morning, Professor Damayanti. No response means we go only one invited speaker effective today. Well, Mr. Liu, I think that we are going through the session questions, so we will give it invites several participants here, maybe more interactive to see your research finding and your products. So are you ready, Mr. Liu? So, well, I will invite all participants who will give a comments into Mr. Liu's speaker.
Sorry, pardon? What did you mean?
Invited the participants to give a comment to your slide presentation, Mr. Liu. Are you ready? Well,
yes.
Yeah. No one comment as well. Is there here in offline more interesting to see in depth
Okay.
Yeah.
And nobody want to ask me
No,
something?
means that's I say this is very effective. Means
Okay.
no doubt. uh,
Yeah. It's it's
oh
interesting
yeah, yeah.
because
Can you show the
Taiwan.
first slide, Mr. Leo, first? Because someone here in
My slide.
offline want to see your first slide. Can you show?
Okay, wait
Yeah,
a
yeah,
minute.
yeah,
Okay, the slide.
yeah.
Okay, yes. Eh? Oh, wait a minute. Let me restart it. The slide should be. Okay, then will be more clear.
Not, no, absolutely not. Ah, right. So we go through
Yes.
high yield from friendly farming, integrated crop management for healthy fruit trees. Do you have a comment, sir? Okay, can you introduce yourself to Mr. Liu?
I am Nguyễn Viết Nghị from Vietnam, and I look at the presentations. At the slide about 5% liquid fertilizer liquid. I don't know. Please, can you show? Yes, slide about 5% of the liquid. Yes, yes. So
Okay. You want to?
no,
Okay, let
why?
me introduce more information, right?
Yes, yes. Please, can you show? Yes. I don't know
Okay.
pyroxene because in English I don't know what is it,
Yeah,
and
pyrochitin,
and
yes.
why only 5%? Okay, thank you.
Okay. Actually, pyrochitin is not fertilizer nor pesticide. Okay, it's something very interesting product. It's for the soil, like maintenance, or for the tree health. Because the chitosan could we say control the bacteria or fungi. Also, the pyrolingenous acid is good for soil to release or to restructure. Now, because once we use too much fertilizer, actually sometimes, okay, let's say something different. If we want the crop growth better, then we should care about our soil, not only the fertilizer, but also the soil health. Then the pyrochitin is to make sure the soil always active. Then why the soil is active, or sometimes we say dead soil, okay, because of the microbiome. So we use the pyrochitin to make sure the soil structure is good enough for the, we say, probiotics or microorganism. Yeah. Then also when this spread to the leaves, so it could protect the plant to to control the virus or bacteria, to make sure the bad bacteria will not affect our crop. In the same time, when we use the pyrochitin to the soil, can also make sure the soil health and make sure the soil not only contain the fertilizer, but also can release good organic acid. Yeah, we can see there are three benefits from here. So actually, we will not, in Taiwan, we will say the pyrochitin is a fertilizer or pesticide. It's more like kind of, we say, plant biostimulates. It's something very useful, like vitamin for our human. Yeah, and this is the result as we see. It could control some bacteria. At the same time, we make sure the soil is good growth for crop. Yes.
So if you more, you can talk the comments if you want to. Okay. Leo, so I have some comment about this. Sorry about if I am misunderstanding about your slide presentation and knowledge, but let me tell that some pyroketin, and the first question is do not tell me how the mode of action this. Do you not tell me us about the how this mode of action is it typically induced resistance or killing strike away the pest in the plantation.
Then I cannot hear you.
Oh,
I
all right.
cannot hear your question clearly.
All right, wait. Mr. Leo, are you okay? Can you hear me? All right.
Yes, much better.
Yeah. So my comment first is you do not tell me about the mode of action your product 5% pyroketin. So what typical mode of action your product has? Is it like induced systemic resistance? Or the second, is it strike away, killing the pest if we implement into the plantation? Is it first question. The second is there any residual? You still not reaching out our comment? You don't know, you don't
I
hear me?
cannot hear you clearly. The microphone's voice is not stable.
Not stable. Well, okay.
Yes.
To be more simple, your product, how is your mode of action? Is it like induced systemic resistance, or is it your product killing strike away the pests in the plantation when we apply? This is my first comment. The second comment is it like a chemical substances? Means if we apply into the plantation, it might be having a residual on the leaf, on the tissue, or somewhere else in the plantation, right? My question on this: how long the residual can persist into the plant tissue when we apply? Because we apply by spray, right? Is it apply by spray, or we just pour into the soil or something like that? But the important thing is you don't know, you understand what my question is?
Yes, I will try to answer you because
All right.
seems
Okay.
not really clear.
Okay.
Okay, I will show you
Mode
the
of
idea
action.
of
Yeah. First is
this
mode
photo.
of
Yes.
action. The second is about about the residual if we have has in the plantation, and how long the residual can persist the your product, right, in the loop. Thank you.
Okay. Like I said, the pyrochitin is not fertilizer or pesticide, but it indeed has some we say functions, like say induce plant immunity, improve the soil properties, and control pests and diseases. Okay. Like I will apply it like 1,000 dilution ratio to the for guava trees. Once a month or twice a month. Make sure, okay, it's like some alarm, or make sure it's like by stimulate, like make the my guava feel like alert or warning. Then they will say, oh, is something wrong? Then I should make sure my leaf gets stronger, or I should make my root stronger. Okay, and first part, it could control the bacteria or bad fungi. The second part, because it's like something stimulates, it's a plant stimulates. So it will make the trees more healthy. But because of the alarm, it's like a warning that the plant not in a very comfortable situation. We make sure the mechanism of immunity of the crop can defend more stress from the outside. Like I say, after applying the phytochitin to my guava trees, and also aligned with the organic fertilizer, I I do have the four good successful result, like reduce the fruit drop. Because in Taiwan we are facing typhoon every year, but the guava and we facing typhoon every year between like July to September, sometimes to October. Then for guava, this is the timing to have a fruit. So we must confirm that the flower will not drop. Okay, so we reducing the fruit drop. The second is mitigate pest and diseases. Like I say, the pyrochitin is a good and we say the material is from nature and the ocean. Okay, so after the biotechnology to combine in our material, we can mitigate pests and diseases. But it's not really good to talk about the theory. It will be like 2 hours more. And then you can see this picture, not only the guava, but also I have the salt culture. So make sure the soil is not exposing under the sun, but also can make sure the temperature and water management. So in this farm, we never use the irrigated system. We use uh, the salt culture to make sure that from spring to winter, we always have a good temperature and water management. Then actually, if you have time, all the students in Taiwan is welcome to visit this farm because it's very easy to find the earthworm. It means the pyrochitin, after using the pyrochitin, not only protect the plant, but also the creatures. Yes. Okay, this is my answer, if it's okay.
Yep. Thank you very much. But actually, the point is not really good to me because of I just want to ask you about the mechanism. Then if the any residual, if you apply in the plantation, I say how long does it take in the plantation? So that's why. But you don't tell me the all process with that. But I drop a chat into chat session, then she can answer probably better than give you a
Yes.
talk with that. Yeah, thank you, Mr. Lu. I think this is a good timing because of the slot time is 9. You will finish the presentation about 9 with discussion, and then we already very much, Mr. Liu, and we do appreciate with
Thank
your
you.
slide and your time. Thank you very much, Mr. Liu, and have you see you again in the next conference or something like that. Thank you. Well,
Thank you.
uh, invited speaker and the participant. Today we go through the next invited speaker, Mr. Mohlis Bahrani. Mr. Mohlis Bahrani. Hello. Is there any confirmation
Hello.
before
Okay.
that? Yeah.
Hello. Good morning.
Ah,
Good morning, Mr.
finally.
Moderator.
Thank you very much. Right. How are you?
Very very good this
Very,
morning.
very good. Good. Are you ready to deliver the talk today?
Yes, as you already scheduled for me.
All right. All right. Yeah. This is first time to meet you, Mr. Mohlis, but I think that's
Nice
more.
to meet you, sir.
Yeah. Well, I'm not repeating the our talk before. This is your turn as a second invited speaker, and then and I think that you are ready for now to deliver the talk. And then is it done? And then time is yours now. So go ahead.
Okay. Thank you, Mr. Moderator. the honorable speaker, Mr. Liu Hung Si. So I wrongly call your name maybe. And Professor Damayanti and other lecturer and academic person, ladies and gentlemen. Firstly, thank you very much for the time given to me for making a presentation of let's see my topic. Give me time. Get me give screen share. It's clear, Mr. Moderator. It's clear my slide.
Yes.
Okay.
Now appears now very clear.
Okay, and 2 months ago, Miss Professor Meta chat me asking me to give a contribution of in this FSSAT event. So I'm trying to make a topic. Hope this relevant short connection with the general topic, the main topic of this seminar. The topic for this time: industrial scale agriculture and food technology innovation in industrial village model. So I want to give an idea that this to fulfill the quantity what big company or finished food product industry on raw material from agriculture product. So this industrial value model can let's say can probably fulfill the quantity of raw material, agriculture product raw material to process further for finished food product. There are 3 points that we want to talk for this time. The first point: prospective seasonal agriculture product processing, and the second point: industrial village model of food ingredient industry, and the third point: innovative technology to create product innovation as an illustration. As we know that why agriculture product why agriculture product should be processed? Why? Because agriculture product is commonly seasonal product, so we should process as much as possible when the crop season is coming. So the quantity, the capacity of the production should be enough to provide along the year what industry need. And we know that agriculture product is easily spoiled. The water content is high. So in agriculture product should be processed immediately with technology. And then the third point, bulk density. That means value, the high value or value of component in a product is less than low value component. So that's why the factory, the processor should be close to the plantation, to the farming. And the fourth, quality is very, very various. So we have to make a standardization in order that the ingredient we produce fit to finished food product industry specification. And then the value is low. The value is low, so that's why we have to process further. And the food ingredient business is very, very profitable. If finished food product industry buy directly the raw material, what I mean, agriculture product directly they buy for their consumption only. So the quantity they buy Q2. So the cost, the price of agriculture product is high. But if food ingredient industry buy the agriculture product to be supplied to many finished food industry, so the quantity is much more. Let's say the quantity is Q1, so the cost is C1. So there is a big gap on buying price. So this converts to the profit for food ingredient industry. So that's why the cost of food ingredient product cheaper than cost of agriculture product if finished food industry buy directly. They process by themselves. It costs much more. So how many processors who involve this change of agriculture product from farming to industry? We can see here the first processor, oh, so sorry, this is the first two. Oh, this change. Actually, the first processor is basic food ingredient industry. This is the first processor. So this change. And then the second, oh, no. This is connect with the next slide. Sorry. Okay. So the first processor of agriculture product is basic food ingredient industry. And the second, the advanced food ingredient industry. So there is two category of food ingredient industry. The one, the basic food ingredient, and the second, and the next is advanced food ingredient. So there is two category of food ingredient. The intensive technology is in advanced food ingredient industry, not in the basic food ingredient. Okay.
I'm sorry,
And
Mr.
then-
Molis, sorry. I
Yes.
just want to tell you that the slide show only 20 minutes and we can discuss later, right?
Wow. Okay. So the time is okay. And then this food ingredient can be supplied to food service, restaurant, I mean, big scale industry, finished food industry, and small, medium enterprise industry. Okay, this is the character of the user, of the consumer, of the buyer. The first food service, we can see here with some character what they need from the agriculture product, the fresh one, and they cook with the additive and with the finished food ingredient. They put together in the bowl in the kitchen, and then the food ingredient for basic process. So that mean from agriculture product, the process to be like a dry corn, like the dry cassava, cheap dry cassava, something like that, and the cocoa bean, something like that. And then this product should be processed further in to be advanced food ingredient product. So this intensifically technology is here. So the more advantage of food ingredient, the more advantage of finished food product. Okay, the time is limited. Okay, so the concept, the model is industrial village model. We know already that the finished food product industry is not interested to buy agricultural product directly, because the quality is not the standard, and the product availability is seasonal, the price is very fluctuative, and other constraint they face if they want to buy directly from the agriculture product from a farmer. So that's why food ingredient industry is very needed to fulfill the quantity, the number of uh, uh, raw material to fulfill finished food industry capacity. The concept is industrial based model. We call it OVOI, one village, one industry. That means one village means one territory in district region where, okay, whereas one industry means one food ingredient industry that process a certain agriculture product to be supplied to finished food product industry. So there are two zones. So the village, the industrial village consists of two zones. We call it one plasma zone of small food ingredient industry, 50 until 100 small industry who produce the basic food ingredient. And then these ingredients, basic ingredients, supply to one industry of advanced industry of food ingredient in core zone of industry. And in the plasma zone of industry, the technology applied here not so complicated. It's a simple technology, commonly physical process. But in advanced food ingredient industry, so this more complicated step of process. Finished food product industry technology is not so complicated, because the quality, the advantage of the raw material is already supplied, already provided by food ingredient industry. So the process intensively technology is in food ingredient industry. So this intensive technology available. Okay, and then the third point that we want to talk about, we want to talk innovative technology to create product innovation as illustration. Let's see, shell corn. Shell corn is, we have we have a huge quantity of shell corn, but now only supply to feed animal industry. So we can create the product from this shell corn, and the dry shell corn from the farmer supply to small industry of food ingredient to make corn flour and broken germ with fiber. So the process is cleaning, grinding, cyclone separation, filling, and packaging. And then this flour and broken germ will be supplied to other part of industry. Flour corn supply not corn starch, but corn flour, supplied to food ingredient industry, advanced food ingredient industry. Whereas the germ is supplied to animal feed industry. So the total value is much higher. The value much higher. So the corn flour we can process to be brown sugar liquid with a very, very high price compared to the shell corn itself. So the process is mixing, alkalination, wet crushing, hydrocyclone separation, cooking, enzymatic hydrolyzation, evaporation, partly caramelization, mixing, filling, and packaging to be brown sugar liquid. The price is almost 2.5 times 2.5 US dollar the price of brown sugar liquid compare with the corn shell corn itself. And then the second illustration is cocoa bean. Cocoa bean, unfermented cocoa. So we always talk about the fermented bean, but now we talk about unfermented bean, where fermented is processed, is done. The fermented process is done in chocolate powder, cocoa powder, I mean. So the cocoa bean is grinded to be powder, and fermentation is applied to on cocoa powder. So fermentation is not occurred in cocoa bean, but in cocoa powder. Why? In order that the fermentation can cover all the part of the particle, not only surface on the cocoa bean. Okay, so we call it semi-wet fermentation. Only a few hours is enough. Okay, then we make a pellet. The cocoa powder, we make pellet, and then we dry, filling and bagging. This pellet cocoa pellet, I mean, is supplied to cocoa processing industry. The technology is sorting, fluidizing, roasting, press extraction, ultra speed colloid milling without conching. Conching takes time 4 hours. It's the long technology. Okay, so the advanced technology is ultra speed colloid milling. And then we take the aroma, we reconstruct the component again, heating, tempering, filling, cooling, packaging. So we extract the polyphenol, we extract the alkaloid, and we reconstruct with the cocoa butter to be cocoa mash. Okay. And the third illustration is cassava. There are two main components in cassava: tapioca starch and cassava fiber. But we always think tapioca starch. If we see cassava, we think tapioca starch. So we leave cassava fiber benefit. Okay. But now, if we see cassava, we think about the caramel. We think about caramel with the higher price, higher value, and also the fiber is a high value. The price of fiber is almost 1.5 US dollar compared to the cassava itself. So how is the technology? It's not so complicated. The simple technology. Okay, so you make celery of the tapioca cassava, I mean the raw cassava. We clean, we make a skin removing, and then we cutting, washing, and steaming, yeah, and then filling, supply to the industry. What industry? Advanced food ingredient industry. So this this cooked cassava is processed further to be what? To be caramel liquid. This is the technology that can we apply. And then we spread the caramel, the sugar, let's say glucose, for example, we spread with fiber. So we will result cassava fiber with the high value, 1.5 US dollar the price.
Excuse me, Mr.
Caramel
Mulis.
price is
Excuse
higher.
me. 5 minutes remaining. Oh, finish.
Yes, finish,
Oh, cool.
Mr. Junaid.
Okay, if you want to.
So you
yeah.
you push me.
No, I mean, if you want to still want to deliver the talk until 5 minutes later, that's
Okay.
okay. Yeah, go ahead.
Okay, thank you. So what I want to emphasize this presentation. We not I mean if we think how to fulfill food industry fulfill raw material what food industry need, we not only think we have to develop the big plantation, not so if we can manage the small farmer, the small plantation, the small farming in the one in certain area, certain territory in the one district. So we collect this product and we supply to small industry. We educate them to produce 1/4, 25 of finished food product, only 25% finished, not 100% finished, 25% finished, to keep the quality as fast as soon as possible. So the big quantity we divide it into 50 until 100 small industry. So the cost of process is cheaper. That means a long process, long change process, long step process, we partly divide it into the small industry with the small machine. They pay the salary for themselves, so their family can work together in the small industry to be 25% finish of food. We call it this basic food ingredient, and then this basic food ingredient supply to advanced food ingredient. Okay, applying advanced technology to fulfill the feature, the benefit, the advantage what finished food product industry need. Okay, so this is more efficient compared to we spend much money to develop the big plantation to fulfill a number quantity of raw material that needed by finished food industry. So by industrial village model, one village, one industry, one village, one industry. So we contribute to small industry to participate, to give a contribution to provide basic food ingredient for advanced food ingredient industry. So this is the concept. Small, collect together to fulfill a number quantity what finished food product need. That's all my presentation, Mr. Junaid.
You finish? Oh, thank you very much. Thank you very much, Mr. Mulis.
So we provide
we
the
do
time for
appreciate
discussion
it.
further.
We do appreciate that your slide ends before the times end. Then, well, we do appreciate your slide, and you try a very enthusiasm presentation, and I think that's a more interesting. Many participants on this platform will deliver the comment with your slide, and but just hold on. We will next session in the question and answer after the last invited speaker hand. Well, I will invite the last invited speaker, Professor Damayanti. Uh, Professor Damayanti will speak about regenerative agriculture for sustainable food production and environmental restoration. So, this topic will deliver about what is regenerative agriculture, and then how about that for the functional for sustainable for production and environmental restoration. But more detail, the speaker, Professor Damayanti, will speak about. Good morning, Professor Damayanti. How are you?
Good morning. Fine,
Yeah,
thank you. Thank you for the
last time
invitation.
we met in the Bali in the Follow Netsin conference, I think. Yeah. Right. I can see
Yes.
clearer than yeah. You're still fresh, right? Well, I think that's time is your. Are you ready now, sir? Prof. Sorry. Yeah.
Okay,
Times is your.
sure.
Go ahead.
Okay, thank you. So good morning, everyone, and thank you so much for the organizer for
But
inviting
sorry,
me.
the
Allow
time
me to
is
share my
your slide.
screen.
Your slide is 30 minutes from now. Go ahead. Yeah.
Okay. Okay. If you can tell me 5 minutes before my time, so I can cut it short if I'm too long.
Sure. I will give a sign for you 5 minutes before you end. Yeah.
Okay. So the title of my presentation is Regenerative Agriculture. Okay. So this is the title, Regenerative Agriculture for Sustainable Food Production and Environmental Restoration. So the gist of the presentation is on regenerative agriculture itself. I will start with the definition and the concept of RA, and then some case study, particularly focusing on the restoration. And then after that, I'll be pulling up, trying to connect that to sustainable food production. So the ending is about sustainable food production, which I will be focusing on food system concept and how regenerative agriculture is linked to the food system concept. Okay, so first let us discuss about regenerative agriculture. Well, first of all, why are we talking about regenerative agriculture? Well, because among others, as we can see here in the slide, we are at a crisis. Our planet is at a planetary crisis where we see the many of the planetary boundaries have exceed what is the maximum of the boundaries itself. So if you can see here from 2009 to 2025, there's an institute in Stockholm, the Stockholm Resilience Center. They have measured the planetary boundaries, which they define as, it started as 10 boundaries, but now it has
Um, I think that's the last invited speaker had technical problem about the internet. Yeah, it's not here. Yeah, that's true. So we waiting or wait. Uh, while we waiting, Professor Damayanti, we can goes to the question for Mr. Mulis. If Mr. Damayanti, if Professor Damayanti has, so we will continue the talk. Yeah, for Mr. Mulis Bahraini, this is all in the chat platform. I will- then you can answer later on. So this is from Febriani Intan. The question is, um, in your study program, we in Febriani study program, she built a teaching factory. She has a teaching factory currently focusing on cocoa and coffee. So C questions goes to about the polyphenols and alkaloids. So can you explain, Mr. Muhlis, how this process work on cocoa? Mr. Muhlis? Mr. Muhlis, can you hear me? Oh, is it not technical issue? I think Mr. Muhlis still here in the platform Zoom. If I can answer this question, I will deliver the talk, but I don't know. So another question is for Mr. Muhlis. Based on your experience, Mr. Muhlis, and your observation, is it possible to develop a food ingredient industry in Sulawesi, particularly if we are aim to establish an industrial village model, at least in the form of the industrial cluster or plasma industry? Mr. Muhlis, are you still with us? Oh, okay. So we're gonna do now. If the committee can show maybe the music to in between until our invited speaker tune in. Prof. Damayanti, I don't think so. She lost connection, so we are really sorry about. So, the Muhlis is here, but yeah. So, I mean, if nothing happened until 5 minutes ahead, so we'll finish. So means I'm happy then. Oh yeah. Oh yes. Prof. Damayanti, are you still? Okay, right. Yeah.
Yeah, so sorry,
No
sorry.
problem. No problem. We understood. Yes. Go ahead.
Okay,
Yeah.
okay, let me start again. So I hope it will work this time. So sorry, everyone. Okay, so basically I started on this, the planetary boundary crisis. Basically, where we are right now, we have from the 16 boundaries, we have crossed 9 boundaries have been assessed, 7 has been crossed. Okay, so this is where we are now in 2025. Basically, our situation is quite bad. If this is green, it means that it has been crossed. So, for instance, the novel entities, this means a chemical compound that are out there that was created by a human, has already been crossed. And then also the land system change, biogeochemical flow, everything was just being crossed. So there are only 2 boundaries that has not been crossed, and that's the stratospheric ozone depletion and the atmospheric aerosol loading. But this is only a matter of time before we cross. Okay. So with that in mind, this is where we are right now. We are at a crisis where the situation is quite bad because of the Anthropocene activities that are conducted by humans. So if we look at that and then we link the food system, what is the link between the situation right where we are now and the food system that we have created? Well, basically, this figure is showing us that the food system which we are producing, whether it's crop, it's livestock, has resulted in pollution, and also there's biodiversity loss. Yeah. And it is affecting the socioeconomic benefits, but also the socioeconomic system is affecting the food system, and the food system is affecting the climate system. So there is an interconnectedness between our food system and the climate, and also the food security. So I think before we start, I just want to stress this out, that agriculture and food system is closely linked to the climate and the effect of the food and agriculture toward the climate system. So that is why we need to learn about regenerative agriculture. Regenerative agriculture is basically, we believe that agriculture is not producing biodiversity loss. It should not contaminate the soil, but we need to regenerate agriculture so that agriculture is part of the environmentally friendly technology. And the basis of regenerative agriculture is that we look at nature. Yeah? So nature is basically constantly teaching us. And so regenerative farming must be prepared. We need to prepare to learn, to listen, and to take on new things. Okay, so I think this is the gist. This is very important. In regenerative agriculture, we need to listen and we need to learn and we need to prepare to be taking on new things. Because what is meant by regenerative agriculture is actually a change of paradigm. So what is regenerative agriculture? Actually, there are many, many definitions out there. So if you can go out into the internet and you can just look at the various kind of definition. And so some has mentioned that organic agriculture is regenerative agriculture. Some has said that agroecology is part of regenerative agriculture. And so this is taken from a theory of change of regenerative agriculture. And the authors stress for them regenerative agriculture is about the agronomic consideration of regenerative agriculture is actually restoration of the soil health and reversal of the biodiversity loss. So one will be conducting regenerative practices. Okay, so the gist of regenerative agriculture, according to these authors, is that we have to practice regenerative technologies. Okay, and this will affect the farming and the food system. It will reorient the farming and the food system, and therefore we can then capture, or we can achieve sustainable agriculture and food system. So this is one author saying that. And the agronomic principles, according to this author, and this is also taken from Maguire, Burgess, and Murfield. These are the principles. So it's basically about technology, about tillage, maintain soil cover, building the soil carbon, foster plant diversity, integrate livestock, avoiding pesticide. Yeah. So therefore, with regenerative agriculture, what we have achieved, what we will achieve is restoration of the soil health and also the reversal of the biodiversity loss. Okay, with other people, this is from the Wageningen group. The Wageningen group, for them, the regenerative agriculture definition is about practicing the inclusion of using the cover crop, retention of the crop residues, using organic input, integration of livestock, integration of multiple crops, and then the exclusion of no agrochemicals, no chemical fertilizers, reducing or eliminating tillage. And so the outcome is about improving the soil health, we sequester the carbon, also increase biodiversity, and hopefully have to be also improving crop production. So this is from the Wageningen group. And so also the Wageningen group is focusing on soil health, soil health and processes which will produce the ecological function. So another group is saying that, regenerative agriculture is not enough by just using the technology and the ecological principles, because regenerative agriculture requires a radical renegotiation of our relationship with the environment. So this group, Seymour and Connelly, they stress that humans need to think more than human. So there is a relational approach that human has to have with its nature. That's why regenerative agriculture, according to them, is more than human ethic of care. So we need to see beyond human. We need to see the biodiversity, the soil health as part of, as equally as important as human life itself. So actually, all the others that have preceded this evolution of thought have been doing that. But what is different with this Seymour and Connolly, they're just stressing that looking at the soil, looking at the biodiversity is not mere just ecological and technological principles, but we have to approach them as a relation. We need to have relation with our nature. So that's what is meant by more than human ethic of care. So we still emphasize social structures and relationship as the basis of environmental change. So basically, the point is about relational approach. We shift our mindset toward more holistic and relational understanding. And this will be the point of my discussion or my presentation today. It's about how we change our relation with nature. That is about regenerative agriculture. So again, according to this author, Seymour and Connelly, by conducting regenerative mindset, we need to relinquish our control, and we have to have trust in the complexity of natural system, because restoring balance of the natural system means that we need to trust and to basically we respect the complexity of natural system. And then we understand the interdependency. And so we have this reforming relationship between human and nature. And we have a conscious action about who is being present and who are the surrounding. And this is the important one. The world are seen to be organized with humans rather than for humans. If in the past we see that everything is for humans, now we have to look that human is part of the nature. So the world is seen to be organized with humans in it. So it's not for the best interest of humans, but it's for the best interest of overall of nature itself. That means we need to understand the nature-based system, and the outcome is about healthy soils, healthy plants, healthy animals, and also healthy people. So we are standing on equal ground. Okay, so that means we need to reform our connection with the world, and other species is becoming relevant again. So this is about regenerative agriculture. And the methodology to achieve regenerative agriculture is we have to have regenerative decision-making and regenerative relationship. And this means that we need to have the power dynamics. We have to understand the power dynamics. And then we have to valuing the species. We need to have a holistic approach. We need to be responsible. So I think, regenerative agriculture, if you want to conduct regenerative agriculture as the paradigm shift, we need to change a lot, because we are talking about the power dynamics of the interrelationship, and then finally we will get the well-being, okay? So this is another point. Being regenerative is not something that is simply or statistically achieved. So we are not just talking about statistic, because it's more than just statistic. It's about understanding our relationship with the nature and the interpersonal relation and the ethics, okay? So this means that economy, if you're just thinking about economic growth, that is not part of the regenerative agriculture. This is one of the things why I said that we need to change our mindset, yeah? So this is a very good picture of what regenerative is about. So actually, when we are discussing about regeneration, we move beyond sustainability, okay? So let us look at this picture here. What is the difference between sustainability and regenerative, okay? So in the past, with Green Revolution and everything else, we have done a lot of damage to the environment. That's why we have been undergoing degenerative processes. And then one day we discovered about how bad we did to the environment, and we stopped the destruction, and we have achieved sustainability. So sustainability is about sustaining where we are now. So we are at a status quo, and we then sustain. Regeneration is about finding a new balance. So we need restoration is part of regeneration. Okay, so regenerative is moving beyond sustainability because regeneration seeks to create new balance. We create new balance, we have new resilience, and we are not just merely preserving the existing condition. So that's why restoration is a big part of regeneration. But then the question is, how can we do that? Yeah, where are we now? This is where we are now. Sustainability is here, and we need to regenerate. So how can we do that? Okay, so if we have been in the past, yeah, sustainable, degenerative over here, and then we are here, sustainability, we need to go to be here. Regeneration is here. We need to have a living system design. Okay, so regenerative design, we have to actively rebuild, we restore, we regenerate the health, the spirit, the culture, and the place of all beings. So that's why, if we are talking about regenerative agriculture, we are also discussing about regenerative development, which means regenerative developments. It includes not also the politics, the economy, the society, Mother Earth, but also it's about spirituality. So this is the holistic approach of regenerative development, and regenerative agriculture is part of that. So the next question is regenerative food production new? Yeah. So when we are talking about regenerative food production, regenerative agriculture, is it something that is new? Well, it turns out not, because maybe the term regenerative is now very popular. People are using those words, yeah. Actually, our indigenous community and our other local communities around the world, they have actually been conducting regenerative agriculture all their life, yeah. They have regenerative food production, and also they understand what is the relationship, the holistic relationship between people and nature. So this is just showing you that our indigenous community has actually conducted regenerative agriculture. So again, this is not something new because we have done in the past. Yeah, this is from the Masyarakat Sungai Utik, yeah, in the Iban tribe in Kalimantan. They conduct regenerative agriculture by using, they are planting citronella, they have beehives, and then they have rice paddy field or paddy ladang, yeah, dry land paddy, and then they have different types of way to combat the pest by using traditional method, and then also they understand this holism aspect. But of course, this is regenerative agriculture using the indigenous knowledge. So the question now is, how can we conduct regenerative agriculture by combining traditional knowledge and Western science, okay? So with that, I think this is where biocultural diversity comes into play. We understand the past about the interrelationship between biodiversity, cultural diversity, and the modern technology. That is biocultural diversity, which is an important aspect of regenerative agriculture. And again, this is just showing the Sungai Utik community where they are planting rice is not only for food security, but also to preserve knowledge and the preservation of nature. And they believe that rice is a living force. Okay, so this is what is called as biocultural diversity. So biodiversity is not just an object to be planted and to be exploited for human, but it's about how respecting nature and biodiversity is part of that. So this is what I meant earlier. For regenerative agriculture, this is the question that we need to ask. We have the Western science, yeah. We have so many technologies. We have so many theory, the cell biology. We have many mathematical models, yeah. And we have the traditional native knowledge, yeah. So where can we meet? What is the common ground between traditional knowledge and Western science? This is where we need to find where is regenerative agriculture from the perspective of Indonesia. So this is a question that I'm posing to all of you. The stress is being regenerative is not something, again, that is, I'm just reiterating, it's not simply statistically achieved, but it's something that you have to embrace because it's about ethics and it's about understanding the relationship. So now let us go to the second one and understand what is regenerative agriculture and restoration. I will be going very quickly because I know that time is running out. I just want to show an example of regenerative agriculture that has been conducted in the Jambi province. And this is regenerative agriculture that has been conducted in the oil palm plantation, okay? So this is a project that I was involved in Jambi for 12 years, where we developed a tree island in the midst of the monoculture of oil palm. So what we did is that we cut down several areas of oil palm with different sizes from 25 meters square, 5 times 5, 10 times 10, 20 times 20, and 40 times 40. And then we plant different trees. So we plant 6 different trees. And then this is being planted in the midst of the oil palm. So this is what we call as the tree island. And our result shows that this tree island enhanced biodiversity function and oil palm. So this has been conducted for the past 10 years, yeah. And the result shows that the species richness, the green one is the tree island, and the brown and the gray one is actually the control with the tree island. And in this part, we see that the species richness has increased in areas where we have the tree island, and then the diversity index has also increased, and also the ecosystem function of the area where we have planted more trees have also increased. The ecosystem function here is the presence of the biodiversity and the pollination and the decomposers and the predators, yeah. So we have measured all of that. And we see by having tree island, it has increased the species richness and also the ecosystem function. And then, so the tree island significantly increased the species richness, and the oil palm yield. The oil palm may be decreasing by 24% within the tree island, but then when you measure at the landscape scale, it turns out that the yield is the same, okay? So you have to look at the landscape scale for the product, not at the island scale, because at the island scale, you cut down the trees. Of course, you have the decline in the productivity. But looking at the landscape scale, then it doesn't, no difference. And the ecosystem function also increased. Okay, and then the second example, case study, which I want to share, is actually, again, in the oil palm system. And this is where we do restoration in the riparian system. So this is a different kind of restoration that has been conducted in the riparian system, and this conducted in Riau. And then the last system is actually intercropping between banana and oil palm, and this is conducted in Bengkulu. We just finished this, so we haven't had the data yet. But this is a collaboration with the Wageningen University, where during the replanting, we are also planting the bananas. And here you can see that the biodiversity, of course, we have increased the biodiversity. And so we plant replanting of the oil palm, and then we have bananas in the midst. And so when we look at the vegetation root structure, the canopy layers have increased, and the lead penetration is not that high. And then the dominant plant, we have much more plants that are available, where in the oil palm you only have grasses and herbs. In the banana oil palm, we have shade-tolerant herbs, we have creeping species, and then the ground cover is much more dense, and we have more layers. The layers are more thick, and the microclimate is also cooler and moisture, and more stratified diversity of the plant. So because I'm an IPM expert, the question is IPM part of the regenerative agriculture? Yeah. And the question is, this is the IPM principle. The IPM principle is about growing a healthy crop, optimize natural enemy, observe the field weekly, and farmers are expert. And this is exactly part of the regenerative agriculture. So IPM principles is actually going hand in hand with regenerative agriculture. So IPM is also a change of paradigm, and IPM is also transcending ecology, social, and politics. So IPM and regenerative agriculture is part of that. Okay, so I hope I still have time because I lost some. I just need 5 more minutes. Yeah, I hope that's okay. The last part of the presentation is about sustainable food production. So let us link about sustainable food production and the regenerative agriculture. So if we discuss about sustainable food, we need to understand a food system. What is a food system? So the United Nations, they developed a food system summit in 2021. And the point of the food system approach is that the United Nations says that it is a way of thinking and doing that consider that food system in totality. So food system is not just agriculture, okay? But we need to reshape the food system where it needs to be also more inclusive of the poor and marginalized population. And we need to be more environmentally sustainable and resilient. So this is what we mean by food system, okay? We have to create the enabling condition. We have to set the multiple stakeholder platform. And sustainable food system is about transformative change, okay? So understanding the food system is using pathway of regenerative agriculture is a way toward developing the food system approach. Okay, and then the food system approach, we understand in the food system approach, it's not only just about the production, but it also involves the pre-production, it involves the production itself, and then it's also involving the logistic, the supply chain, the processing, and then also the consumption. So the whole system of producing until consumption is a food system approach, including the waste management. Yeah. So
1 minute.
Regenerative, okay.
1 minute remaining, Prof.
Okay.
Are you okay?
Okay.
All
yes,
right.
I'm okay. I just have one more slide. So the pathway to regenerative agriculture is very important to achieve the food system and sustainable food system approach. Okay. So this is my last slide. It's going back to regenerative. If we look at this food system and we understand about regenerative again, so we need to think regenerative thinking in achieving the food system. What do we mean by understanding the interdependence? What do we mean by reforming relationship between more than human environment? We need to understand the nature-based system. It's not binary, human versus nature, but it's a humanity where we are nature-based system. We need to reform our connections with the earth. And again, we need to understand that humans is part of nature. So the world is not for humans, but the world is organized with human. So regenerative is the change of thinking so that we can conduct food system in a sustainable way. Okay, so I think my presentation is that.
Thank you very much.
And basically, my presentation is about understanding the link between regenerative thinking and food system
Yeah.
for sustainable future.
I
Thank you.
got the point very clear, Prof. That's really many question about it. I think this is a one of concept. Maybe this is about because of we last time past years talking about the sustainable agriculture. We have an organic farming. We have and then you now deliver talk about the regenerative agriculture. So many audience confused about then the word the typical about, and then of course I think that your slide can answer all things that we have a doubt about. But thank you very much, Prof, for your very interesting topic about regenerative agriculture. Is there any particular question that you want to? Because I heard that you from the committee that you have a class after this slide presentation. Or you still here with us for our audience here? Sorry, I can't hear
Yeah,
you.
I can still be here for another 15 minutes.
All right. Thank you very much. Okay, so we do appreciate in both presenters and invited speaker, and then of course Mr. Molis and Prof. Damayanti Bukhari. And I think that we go through in the question and answer session. So I will read in the chat rooms. There are several questions here. Goes to Mr. Mohlis. Mr. Mohlis, are you still with us, Mr. Mohlis?
Yes.
Oh, thank you very much. All right, I will read the question in the chat so I can help you. So this is from the Febriana Intan. I think that you already read this.
Yes, I just read.
Yeah, Febriana Intan is currently focusing in cocoa in coffee. She is interested in the polyphenols and alkaloid you talk. Could you explain more in depth about the working for cocoa processing or not? So another question from Intan or Febriani. So about your experience, I think, and your observations. Is it possible develop to a food ingredient industry in Sulawesi, particularly if we aim to establish an industrial village model, at least in the form of the industrial cluster or known as plasma industry? Yeah. This is Mr. Molis. Can you start now to answer? Yeah, go ahead.
Okay. Thank you for the question. So we know that unfermented cocoa has polyphenol alkaloid content is higher. I mean, so if we compare unfermented cocoa with fermented cocoa, unfermented cocoa contain more alkaloid, more polyphenol. So what the idea is to make reconstruction. The important component in the cocoa bean, we take out one by one. For example, if we press, we will get cocoa butter. Okay, and the cake, we can extract the cake to get the polyphenol, to get the alkaloid like a theobromine, something like that. Okay, so this valuable component can be reconstruct to be a certain grade of cocoa product, chocolate product, I mean.
Yeah.
Okay, and then the other side, I presented in my slide that if we want to, if we have to choice raw material, I mean cocoa bean, fermented or unfermented. So I prefer to get unfermented. Why? Because we can control the fermentation by ourselves. Not let farmer to do fermentation. So that's I call semi-wet fermentation. The dry cocoa bean we grind to be a smaller particle, and then we add yeast to do fermentation with a bit water, so semi-wet fermentation. So the all part of the particle can be fermented rather than fermentation is done on the surface of the cocoa bean traditionally. That's what I mean. The small industry can do this process under our guidance, under our education, under our teaching to them. Then this product, okay, can be supplied to the advanced food ingredient. So this is system. And then in the food ingredient, the advanced food ingredients, we apply technology, what we call it, extraction, solvent extraction. We can make a fractionation, polar and non-polar, something like that. And we get the polyphenol. We get a bit cocoa butter because when we extract with the solvent, some cocoa butter we can take out a bit, not all. Okay, and then we also get the polyphenol or alkaloid, and then we reconstruct according to what polyphenol, how much polyphenol that we want to involve in our chocolate product to get the certain great quality of chocolate product. So we control everything, not only let the product do, the product does is under our control. So that's why the chocolate product, we can make some grade. This for the middle low class, this for middle up class. If you want to make a very good chocolate product for the middle up market segment, so we add more polyphenol and alkaloid to this compound in order that the mouthfeel, the taste, the astringent taste, the bitter taste of the chocolate, we call it bitter chocolate, much better. Okay, and the next question is industrial village model, whether we can make in Sulawesi. Oh, it's very, very possible. Very, very possible. Very, very possible. And it's simple. We just educate the small, let's say, what we call it, UKM, yeah? SMEs, SME, small, medium enterprise in the one village, let's say, Palopo, what's the name of who has the area who has much cocoa. So we can develop small industry to make 20% until 30% of finished product. Not all product. Not 100% finished, I mean. Only 20 until 30% finished. And what we call it, if we do all the process, so we need many employees, and we pay them all. But now with the industrial village, so the responsibility to pay the employee, we let the small industry to pay them. Okay, and the total investment we divide it into the small industry. So the long process to be shorter, and the responsibility to be lower. So the risk we divide risk, and also divide profit. The divide benefit. Okay, so this the community, the system in the one village, in the certain district. Okay.
Yeah, thank you very much, Mr. Mulis. Your explanation. Now, but if the questioner still curious about the talk, maybe can by Japri ya, or jaringan pribadi. Well, we go through the Damayanti. So no audience here.
There's one question.
Yeah, so
There's
one question for
in the
me.
chat.
All right.
Yeah.
So this is a new concept for me actually, but it's not something new, yeah, because of we already know about the sustainable agriculture, we know about the natural perspective, we know the organic farming, and then now we know now about the precision agriculture. So regenerative agriculture, is it part of agriculture precision? Because precision agriculture is currently emerging now in India. This is my first question, because you not elaborate with that. The second question is, we know now in the government program to known as Swasembada. I believe regenerative agriculture can answer this question, because why? Because of this extensive land needs to provide the food to feed all people in Indonesia. So what do you think about? Thank you very much.
Okay, Pak Jun, thanks. But before that, I'm going to read, there's one question from the chat, so I would like to read that also. Yeah, I would like to answer this before answering your question. Is that okay?
Yes,
Yeah.
sure.
Okay, so there's a question from, I don't know, MS Akili. The question about moving toward a regenerative and sustainable food system.
Yeah.
How can we practically balance the need for large-scale market-driven efficiency with the principle of ecological interdependence and local community-based food sovereignty? This is a very good question. And actually, this is a question that I've been also asking myself, because it seems that in regenerative agriculture, as I mentioned again earlier, that we need to have a shift.
Yeah.
We need to shift our paradigm. And so large-scale agriculture, we need to define how large is large. So for instance, like what we have now for all palm, for instance, regenerative agriculture means we cannot have too large of a monoculture. That's
Yep.
why the case study is putting ecological island and then restoration. So if you are still thinking about monoculture large scale, that is not regenerative agriculture. So your question is, how do you balance? Well, the balance is we need to conduct research, so we need to understand what is the maximum size for a large scale agriculture that can be used for regenerative agriculture. Okay, so this is where the mindset comes in. It's not about production that is most high, but it's about how we have regenerative ecology. Okay, so the mindset is not economic growth, but the mindset is about food sovereignty, about self-sufficiency, and that means we don't need to produce too much for the market, because this will answer Pak Jun, because food self-sufficiency becomes important. So it's about balancing what is the size of monoculture and still gain efficiency. We can still produce for the market, but the market has also, so we have to have different markets in different areas of Indonesia. So it's not like Java produce food for all Indonesia, okay? But it's about Java, Sulawesi, Sumatra, producing food for different parts of the island, but maybe within the island itself. So that's why I said it's about changing the mindset again. That's why it's hard to conduct regenerative agriculture, because our mindset is still the same. So going into the precision agriculture, I think precision agriculture is a tool. So yes, it can be used with regenerative agriculture, because if we look at maybe, for instance, for the water, how much water would a plant need? We need to use precision agriculture for that. So precision agriculture and the tool to be more precise on the use of water, the use of fertilizer, the need for pesticide maybe, it will all be more efficient. So that's the second question from Pak Jun. And the third question from Pak Jun is about food self-sufficiency, ya, swasembada pangan.
Yes.
I completely believe that regenerative agriculture is going hand in hand with food self-sufficiency, because the goal for regenerative agriculture is food self-sufficiency. But again, the question is about the market. Yeah. So if we're thinking that we want to sell our food also to outside country, then it's not about food self-sufficiency, but it's about trade. So that's the issue. But for food self-sufficiency, yes, I believe it can go hand in hand. Demikian, Pak Jun.
Thank you very much. So I hope this talk can be heard by the government about the regenerative agriculture. Yeah. You know that so somebody's a very excessive now, then very extractive lands and landscape changing, then everything like. But I think that's the key point of the regenerative agriculture, so making a new balance and more sustainable about the new balance about that. Thank you very much, Prof. Damayanti. I think that's no more question about you, because of very clear and very scientific evidence about regenerative agriculture. Yep. But before we end of the our session, so we still have several comments to Mr. Mohlis. Yeah, we'll read in the chat room. Hold a minute. So this is a question from the MS Akili.
Akili about fiber.
Yes.
Cassava fiber. Mr. Junaid.
I'm not sure, but it's Akili. The
Yes,
question
yes, the
is:
question
is
is
what
cassava
are
fiber.
functional? What is a functional and nutritional and technological rules cassava fiber in the context of food and industrial application? Is it the first question? And then they have another question, Mr. Akili. But this goes to Prof. Damayanti. I'm reading for that. In moving to a regenerative and sustainable food system, how can we practically balance the need for large-scale, market-driven efficiency with principles of ecology, interdependence, and a local community-based food sovereignty? I think this is both for those invited speakers. So, Mr. Mohlis.
Pak Jun, sorry, I already answered that.
Oh, you already answered.
Oh,
yes.
Before I answered you, I already answered that.
Oh, sorry. Thank you very much. All right.
So I have to go. I have to
Okay.
teach.
So my job will end
you.
soon. Thank you very much.
Yes.
But
Makasih.
Makasih,
Prof.
Damayanti. Makasih.
Prof. Damayanti, can you still have couple minutes, because of the committee will give a talk to you, Mr. Damayanti, Prof. Damayanti? Oh, okay. She disappear. Yeah. All right. So, okay. Mr. Mohlis, that's you get the point. The question. Go ahead.
Okay. So this interesting question. So some academic people thinks the fiber they mostly think functional benefit of fiber. They always think that this is the from academic point of view. Okay, in industry we think more than that one. Besides nutritional, besides the health benefit, functional benefit, there are many physical benefit of the fiber. As you know, that the fiber has the capillarity system. Okay, what's the function of a capillary system? They can absorb the water. They can absorb the oil. Okay, not only for our metabolism, but also for the performance of the finished product. Okay, the fiber can control the water. We call it water holding capacity. We call it the oil holding capacity. Okay, when we add the fiber to the dough of the batter, or the dough of the frying food, the dough or frying, what you call it, frying flour better. So we add the fiber into apa ya, gorengan apa itu Pak namanya Pak Junaid, gorengan yang suka bakwan for example bakwan.
All right.
Okay, so if we add fiber into the bakwan, so the volume of the dough will be more because the water absorption from fiber. And then when we fry the bakwan, so there is the heat shock, heat penetration, heat shocking into the bakwan to make the surface of the bakwan is not smooth. Why? Because the water evaporation, water to be vapor very fast, suddenly. Okay, but with the fiber inside, so the water evaporation, the water come out is under control, step by step. So the surface of the bakwan much better, smooth, and the taste is very crispy. Why? Because when the fiber contain much water, and the water is evaporate step by step, and the oil cannot enter to the dough much. The oil cannot enter much to the bakwan. Okay, so the bakwan taste will be more crispy because the oil content is less. And then when we put bakwan on the open air, okay, so the fiber can absorb the water in the air to avoid the bakwan melempem. So if you use the fiber into bakwan, so you can put bakwan at the ambient temperature, open air, 7 hours at least, the bakwan will be keep crispy. It is the physical function. So many function. For example, as the anti-caking agent, the fiber. Why? So because the fiber can absorb the water from the air, so the powder can be kept free flowing. The second benefit, many benefit, but the time is limited.
Thank you very much. Well, I think that's more interesting, but I think the time is end now.
More one sentence. But by technology,
Yeah.
the starch in the fiber, in the capillarity, in the capillary, you can hydrolyze the starch to make the capillarity more wider, much wider, to absorb the water. From 5 times water holding capacity to be 7 times water holding capacity. For example.
Yeah. Is it okay? The audience can contact you by email, sir?
Yes.
If they have any more in-depth question about, I think that's more interesting. But yeah,
this is good for research.
We will finish soon, and then. But thank you very much for all the invited speaker in this planning session, and Mr. Liu, Mr. Mohlis, and Prof. Damayanti. We do appreciate what your time and what your slide presentation more interesting to us, our audience. But before we leave, so the committee, chair of committee will deliver a talk for both all of you, or the 2MC. So I think that's this is my job enough for me, and I will share the time to the master ceremony. So please go ahead. Thank you very much.
Thank you very much, Mr. Junaid. That was indeed a very insightful and fruitful discussion session with our invited speaker. And now we will present certificate of appreciation to our invited speaker. The certificate will be given by our Chief of Committee of the 5th FSSAT, Professor Arshad. The first certificate goes to Mr. Liu Hongxi.
Thank you very much for Mr. Liu today for your very high quality presentation today, and on behalf of the organizing committee, really appreciate your contribution for this occasion. Thank you very much. And also Pak Muhlis, terima kasih banyak Pak. Thank you very much for giving us very nice. I followed the presentation from the beginning, just like Mr. Liu too, and we found necessity to more elaborate how the processing product of agriculture is really important for us. And thank you very much, Pak Muhlis. We really appreciate, and we show the certificate and will be sent by the committee to you directly. And Professor Damayanti, also we really appreciate of you talking today, sharing experience, especially for local indigenous agriculture, dealing with regenerative agriculture. Thank you very much, Prof. Damayanti. We expect that we can formulate together to how the agriculture development policy make self-sufficiency and food security, including the environmental restoration. Thank you very much for all. On behalf of the organizing committee, really appreciate and see you next time. Assalamualaikum warahmatullahi wabarakatuh, and good morning for everybody.
Please stay on your place, Prof. Arshad. And now we're going to give certificate to our moderator. Ladies and gentlemen, now that concludes all the keynote speaker and invited speaker for today's. And now we would like to remind to all the participants and presenters that our parallel presentation will begin shortly. This session arranged in several rooms, where each focusing on different themes related to our conference theme. Presenter and participants now may proceed to the respective rooms provided by the committee. We will also choose the best presenter for each room, so give your best and happy discussing.
Oke, saya mohon Ibu MC sudah bisa live ya.
Yes.
Oke, terima kasih ya atas
Terima
semuanya.
kasih Bapak.
Mohon maaf bila ada yang salah kata.
Halo teman-teman, sore ini kita masih ada absensi atau tidak ya?
Check. Good afternoon, everyone, and welcome again to the closing ceremony of the 5th International Conference on Food Security and Sustainable Agriculture in the Tropics. After days filled with insightful presentation, discussion, and invaluable networking, it is time to reflect on the incredible journey we've shared and we celebrate our collective accomplishment. Before we conclude, let us take a moment again to express our gratitude to all of you, our speakers, moderators, participants, and organizing committee who made this conference a memorable and impactful experiences. The success of this event is truly a testament to your dedication, knowledge, and enthusiasm. And now the moment we've all been waiting for, the announcement of the Best Presenter Award. The best presenters were selected from every topic for individuals whose presentation stood out for its originality, depth, clarity, and the positive impact it had on our audiences. Before we announce the Best Presenter Award, let us hear closing remarks from the Chief Committee of the 5th FSSAT 2025. Ladies and gentlemen, please welcome Professor Muhammad Arsyad, PhD.
Thank you very much. Today, Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon for all of the participants. Dean of Faculty of Agriculture, and this time represented by Vice Dean for Research, Partnership Affairs, and Secretary of the FSSAT Committee. This time, thank you very much. Today, we just finished all parallel session of this conference, and we collect 250 abstract accepted here in the committee, and we are expecting that those papers will be published for some journals and also proceedings. Of course, we will proceed and follow up of those procedures of reviewing papers for all of you, and I'm hoping that we can quick response in each final email or correspondence from the committee. This time I especially also thanks to Professor Nisanta again with us. He's actually coming from Faculty of Economics and Management Studies of Colombo University, and also few from the Vietnam, and also Ili Dipama. Thank you very much for your coming for this 2 days conference. I'm expecting that you will get a very nice impression for this, and with few is few how to say, I'm sorry to put it, few for your coming here, and all of the participants who already presented their papers. My impression for this 5th FSSAT conference, I'm my small assessment that from the keynote speaker and invited speaker, and also of the all paper submission is to me it's a very giving us new issue, especially in regenerative agriculture, and simultaneously we discuss about environmental restoration. So the issue here we just try to build is how the agriculture development we doing, and we still keeping the good environmental situation. And finally, publishing of those papers, we are expecting as a committee here in the Faculty of Agriculture and Faculty of Agriculture Technology, we will have a new innovation or a new technology we can produce or we can use practically in the field to support self-sufficiency both in national and global food availability. And the last but not least, that as a committee members of this conference, please allow me to say again thank you very much for all of you contribution to this conference. Finally, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor Arshad, for your closing remarks. Ladies and gentlemen, and now for the awaited moment to all the presenters, we will announce the best presenter for each room. And for room number 1, the best presenter goes to Jerome P. Lokosol. Congratulations to Jerome P. Jokosol. And for room number 2, the best presenter goes to Zilda Hairani Zaiful. Congratulations. For room number 3, the best presenter goes to Daner Sagala. In the room number 4, the best presenter award goes to Ahmad Tirta Setiadi. Room number 5, the best presenter goes to Elva Powell. I'm sorry. Congratulations to Miss Elva for winning the best presenter. And for room number 6, the best presenter goes to Muhammad Surirman Akilis. For room number 7, the best presenter goes to Maura Rahmat. I'm very sorry. For room number 8, the best presenter goes to Andi Alfian Darmawan. For room number 9, the best presenter is proudly awarded to Nur Amalia. Congratulations to Nur Amalia. Next, to room number 10, the best presenter goes to Siti Inderiati. Congratulations. Room number 11, the best presenter goes to Akid Mukhtar. Congratulations for your acknowledgement as best presenter. And now room number 12, the best presenter goes to Anissa Kistanti. Congratulations. Room number 13, the best presenter goes to Irenio Seno Prasojo. Congratulations. Room number 14, the best presenter goes to Nurhaya Jepanga. Congratulations. Room number 15, the best presenter goes to Siti Fatimah Andi Paturusi. Congratulations. Room number 16, the best presenter, proudly awarded to Nur Astri Muftia Sanjaya. Congratulations. Room number 17, the best presenter goes to Rizky Widianti Kadir. Congratulations. Room number 18, the best presenter awarded to Dwi Gina Nadifa. Congratulations. And room number 19, the best presenter, it goes to Eli Surya Ibrahim. Congratulations. And now for the offline session, we also have best presenter, and the certificate will be handed directly by the Chief Committee of FSSAT. Please come forward, Professor Arshad. Oh, Vice Dean. And the best presenter for the offline session of the 5th FSSAT 2025 goes to Elise Dopama. Congratulations. We will have another one best presenter. The certificate proudly awarded to M. Ashraf. Please come forward. All right. The certificate will be sent to you through email. And once again, congratulations to all the best speakers. Ladies and gentlemen, as we are now on the closing session of the 5th International Conference on Food Security and Sustainable Agriculture in the Tropics, we would like to once again express our deepest gratitude to each and every one of you for making this event a remarkable success. We hope this conference has inspired you with new ideas, meaningful connection, and renewed passion for our shared mission. Please stay tuned for updates on next year's conference. We are looking forward to welcoming you back and continuing this meaningful journey together. Until then, stay safe, stay inspired, and keep contributing to the advancement of regenerative agriculture for sustainable food production and environmental restoration. Thank you very much, and see you again next year on the 6th FSSAT 2026. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Bapak Ibu peserta, mohon kesediaannya untuk maju ke depan untuk kita melakukan sesi foto bersama. Ladies and gentlemen, please move forward. Please come forward so we could take a group photo session together in front of the Faculty of Agriculture Universitas Hasanuddin. Bapak Ibu silakan mengambil tempat yang telah disediakan.